In 1923, physicist Arthur Compton played out a trial where he bounces photons off electrons, showing that the two electrons and photons were dispersed by the collision. Not exclusively do photons and electrons collide, they collide elastically, which implies that both momentum and kinetic energy are conserved during the collision. As such, the electron and photon bounce off one another similarly as billiards balls would. Energy is conserved when the electron is dispersed by the photon. For an impacting photon and electron, the momentum conservation condition seems to be like the energy conservation condition. Then again, here you are managing momentum vectors. Out of this experiment, Compton found out that the wavelength, which is named after him as Compton wavelength, is as Compton equals 2.43 times 10 raised to the negative 12 meters. Arthur Holly Compton explained that the wavelength increased by considering X-rays as composed of discrete pulses or quanta of electromagnetic energy. In Compton Effect, individual photons collide with single electrons that are free or quite loosely bound in the atoms of matter. Colliding photons transfer some of their energy and momentum to the electrons, which in turn recoil. Then new photons of less energy and momentum are produced that scatter at angles the size of which depends on the amount of energy lost to the recoiling electrons. And because of the relation between energy and wavelength, the scattered photons have a longer wavelength that also depends on the size of the angle through which the X-rays were diverted. The increase in wavelength or Compton shift does not depend on the wavelength of the incident photon. The Compton effect has a very important place in the history of physics because it shows that electromagnetic radiation cannot be explained by purely wave phenomenon. Compton effect gave a convincing argument that the electromagnetic waves can indeed behave like a stream of photons, which placed the concept of a photon on firm ground. Compton effect is the main cause of scattered radiation in a material. It occurs due to the interaction of the photon, the X-ray or gamma, with free electrons or loosely bound valence shell electrons. The probability of the Compton effect is dependent on the number of electrons per gram in the absorbing material, which for most elements is approximately the same. An exemption, though, is the hydrogen, which has no neutrons in its nucleus. Therefore, it has an electron density which is twice that of all other elements. Thus, Compton effect is independent of the atomic number of the observer.